Hey everyone, on this lecture we are going to study the gather and scatter operations in MPI. Both operations can be easily visualized. We are going to see this visualization in a moment. First of all, let us begin with the MPI gather function. This is a collective communication operation in MPI. We are going to discuss its arguments in a moment, but first of all, let us see what it does. This function essentially, when we use it, makes that each process, root also included, sends the contents of its send buffer to the root process. And so the root process is going to receive all of these messages, and it is going to store these messages in rank order. So notice how in this matrix representation, each row is a process. So notice how the first row is the process 0, and when we apply the gather operation, then the root process, which in this case is the process 0, is going to gather data from each process in the communicator. So we are taking this data from process 0, we are taking this data from process 1, this data from process 2, and so on. And once the process 0 gathers all of this data, it arranges it in the receive buffer, as we can see here. And this is done based on the rank. So notice how in the receive buffer we are going to have first the data from process 0, then the data from process 1, then the data from process 2, and so on. So it is important to notice here that when we apply a gather operation, assuming we have n processes, the outcome is as if each of these n processes in the group, including the root process, had executed a call to the MPI send function. And the root had executed n calls to the MPI receive function. At this point on this course, we know these two functions, we know what they do, and it is easily seen here, this analogy. Before showing a simple example of the MPI gather function, let us now delve into the arguments. The first argument of this function is a pointer to the send buffer. This is essentially the starting address of the send buffer on the calling process, the process that is calling this MPI gather. And so this is the data that each process wants to contribute to the gather operation. We then have this integer send count, which is the number of elements to send from this send buffer array. We have also the send type. What is the data type of these elements in the send buffer array? And then we have this pointer, okay, to the receive buffer. This is the address of the receive buffer on the root process. And it is this buffer that will store the gathered data. Analogously, we have the count, the number of elements received by the root process. Then we have this integer root. This is very important. It is the rank of the root process, the process that will receive, okay, the gathered data. And finally, we have the communicator. So essentially the group of processes over which the gather operation is performed. Remember that the default communicator is the MPI word communicator. Very well, let us now delve into a simple example of this function. On the following lecture, we are going to solve a problem, okay, using both MPI gather and also MPI scatter. We are going to code a solution for that problem from 0. On this lecture, we are only going to see some examples, some brief examples of these two functions. Let us begin with the MPI gather. In this example, the root process gathers 100 integers from every process in this group. And very important, notice that since only the root process is going to receive all of this data, only the root allocates memory for the receive buffer. So we check if we are the root. Okay, if we are the root, then we allocate memory for the receive buffer. So as we can see, this send array is the starting address of this send buffer. We have 100 elements. The data type, since they are integers, we say here MPI int, which is an MPI data type for the integer. Then we have the receive buffer that we have allocated in the root process. Okay. We are also going to receive the 100 elements. They are integers, we specify the root, and finally the default communicator, which is the MPI word communicator. On the following lecture, we are going to dive deeply into this type of implementations, and we are going to see step by step how we can apply all of these operations. This is only an introduction lecture to MPI gather and MPI scatter. So let us now continue with the function MPI scatter. Before discussing the arguments, let us see what this function does. The MPI scatter function is the inverse operation to the MPI gather. It is also a collective communication operation that we have in MPI. You notice that with MPI scatter, we distribute data from a single source process that we call the root process to all processes in a communicator. So notice how in this example, the process 0 has all of this data, okay, and it distributes all of this data to each of these processes that we see here, so that each process will receive a segment of this data. And thus, the outcome of this function is as if the root process executed n send operations, MPI send, and each process in the group executed a receive, okay, operation, an MPI receive operation. So an alternative description is that the root process sends a message with MPI send, and this message is split into n equal segments, supposing that we have n processes, and the ith segment is sent to the ith process in the group, right, as we can see here. The message is divided into n segments, and I have n processes, and so the ith process receives the ith segment. So if we analyze the arguments of the function MPI scatter, we can see how they are very similar to the function MPI gather. First of all, we have this pointer, which is the beginning address of the send buffer, and it is a buffer that is used only by the root process. Then we have the send count. This is the number of elements to send to each process. We are distributing data. So how much data is sent to each process? Then we have send type, which is the data type of the elements that we are sending. We have this pointer here, receive buff. This is the starting address of the receive buffer used by each process here. We have also analogously the receive count, number of elements that we are receiving. We also have the receive time, the data type of the elements that we are receiving. Then we have this integer root. This root is very important. This is the rank of the sending process. That is the process that scatters the data. This process that distributes the data. And finally, we have the communicator, right? This group of processes over which this scatter operation is performed. Here we have a very simple example of the function MPI scatter, in which we use this function to distribute the array send buffer across all of the processes. Notice how the size of this send buffer is 100. We have 100 elements, and we are assuming on this example that we have 5 processes, and hence each of these 5 processes is going to receive 20 elements of my 100 elements. Okay, I'm going to receive basically 20 elements for each process, and then this is going to be the size of my receive buffer. But notice, since we have 100 elements in the array, we need to allocate memory for the 100 elements in this send buffer. Of course, each process is going to receive only 20, but in the send buffer we need to have memory allocated for the 100. Very well, and with this we end this brief example on the use of MPI scatter, and we end this introduction lecture to gather and scatter operations in MPI. And now in the following lecture we are going to solve a problem regarding these operations, in which we'll need to implement an MPI program from zero. The following lecture is very important, since we are going to learn in a more practical way how to use these functions and all of their arguments. We remind the student, as always, that you can download all of the documentation on the downloadable documents of this lecture.